It will be helpful to people who want to solve particular questions. Yeah. Now, when I see the fourth question, let f be a continuous function defined on the closed interval -4 to 6. So f is a continuous function from -4 to 6. Very good. And this is what is f. The graph of f consisting of 4 line segments. Yes, definitely it has 4 line segments shown above. Let g be the function. Very good. So this is how generally one question, 100% we'll have one question based on this. G of x is integral of f of x. They try to relate between both g of x and f of x. So g of x clearly it is given as integral of 0 to x into f of t dt. Very good. Now let us see what he is asking for. What are the questions he is asking for? On what open intervals is the graph of g concave of? Give your answers. So first, everyone in the class, I don't know how many of you clearly understood what is concave up, concave down. Definitely concave up means this, something we simply say. But I told you how to relate, and we also know f double dash x is greater than 0 if a function is concave. But understand how we got this, then you'll never forget, and such type of questions becomes very easy. We know concave up if a function is f of x, function is concave up if f double dash x is greater than 0. But see, suppose if I have a function like this, so what is happening to the derivative? Some positive. It is going on reducing. The value is reducing. So we know, listen to me carefully. If you can understand this concave up, we can, then only we can solve the questions. Suppose if I have a function f of x, when I say it is increasing, when I can say the function is increasing, when the value of f dash of x is increasing, means f dash x is not increasing, f dash x is positive. Sorry, I can say a function is increasing if f dash x is positive. Suppose the function is decreasing, the derivative is negative. These concepts we know. F of x is increasing when the derivative is positive, and f of x is decreasing when the derivative is negative. Correct, right? So now relate. F of x is increasing when slope is positive. Take at any point the slope of this function is positive, then I can say the function is increasing. Similarly, I can say f dash x is increasing, f of x is increasing when f dash x is positive. Similarly, I can say f dash x is increasing when f double dash x is positive. So for example, you take a concave up function. What is happening to a concave up function? Find the slope here. Definitely it will be negative because it is making greater than 90. Definitely negative, greater than 90. It is horizontal, so 0, positive, positive, positive. So it is changing from negative to 0 to positive. What is changing? F dash. F dash is what is happening to f dash. F dash is increasing. So if since f dash is increasing, I'll say f double dash x is greater than 0. That is the meaning of concave up. We clearly know, right? So the moment you know this, definitely any question they can ask where the function is concave up or concave down, easily will be able to solve, but you should know clearly the concept behind this. So we clearly know f dash x is increasing when f double dash x is positive. Why? Because f of x is increasing when f dash x is positive. So similarly, if f dash x is increasing when f double dash x is positive, so clearly here f dash x is increasing negative to 0. So if a function is concave up, means what is the meaning of it? Derivative is increasing or f double dash x is positive. I'm very clear. Now let me come back to the question that they had given here. So what is part A? They are asking for. They are asking for in what intervals g is concave up. Means I need to find where g double dash of x is positive or g dash of x is increasing. If g dash of x is increasing, then g double dash of x is positive. That is what clearly I need to find out. But I don't have g dash of x. But they gave me g of x. What is my g of x? G of x is integral of 0 to x f of t dt. We have a beautiful fundamental theorem of calculus. What does fundamental theorem of calculus says? If I have a function f of t, which is continuous in the closed interval a comma b and differentiable in the open interval a comma b, then if I have, suppose, let me take g of x is some 0 to x or a to x f of t dt. So if f of t is continuous in the closed interval a comma b and differentiable in the open interval a comma b, then I can write happily my g dash of x is f of x. That is what is the fundamental theorem of calculus says. So according to the fundamental theorem of calculus, since f of t is continuous and differentiable is a continuous function of the closed interval, the graph is kind of 4 line segments is shown in the figure. So I can write according to the fundamental theorem of calculus, my g dash of x is f of x. Now I need to see where g dash of x is increasing. G dash of x is increasing means f of x is increasing. Both are same because g dash of x is same as f of x. Or you have patience, you can also find where g double dash of x is positive means where f dash of x is positive. F dash x is positive here, slope is positive here. You find the slope. Slope will be negative here because it is making an angle greater than 90. Slope will be negative here. Slope will be positive here. This. So if I come back, according to the fundamental, you need to write all these points. According to the fundamental of the theorem of calculus, g dash of x is f of x. So I need to do this question in 2 ways, where g dash of x is increasing or g double dash of x is greater than 0. So what is the meaning of g dash of x is increasing? F of x is increasing. F of x is increasing from -4 to 6. So the function is concave up from -2 to -4. Sorry, from here to here it is increasing. So here it is -4. Here it is -2. So from -4 to -2, the function is concave up, and where the function is concave up, where it is increasing. If you are getting confused, increasing means you can just say g double dash f x should be positive, means f dash x should be positive, means positive slope. So f dash x will have positive slope here, f dash x has positive slope here. Other way, simple way to understand. So between 2 to 6, but you need to write those words. We know g dash of x is f of x, or g double dash x is f dash x. We know the function is concave up when g double dash x is greater than 0, means f dash x is positive. So f dash x is positive means slope is positive. So clearly the slope is positive from -4 to -2 and 2 to 6. So in these intervals, the function is concave up. If you are good at free response questions, even the multiple choice questions, you'll be good. Multiple choice questions are subset of free response questions. And these are all actual previous year questions. So you'll get a similar questions. And none of the questions are difficult. Only the thing that you need to do is you need to apply the base. How simple is this? How simple is question number 1? I hope everyone is clear. So first try to understand when the function is concave up, not trying to understand answers here. If you try to understand answers, definitely you'll get answers. I'm sure about it. Okay. Yeah. Now, so let P be a function given by P of x is equal to g of x into f of x. Find P dash of 3. Simple question. They give P of x is equal to g of x into f of x, and they're asking P dash of 3. P of x is g of x into f of x. Now P dash of x is equal to g dash of x into f of x plus UV rule, g of x into f dash of x. But I need to find P dash of 3. So P dash of 3 is given by g dash of 3 into f of 3 plus g of 3 into f dash of. So now I need to find these values. I don't have an option. So simple value is f of 3. Next simple value is g of 3. G of 3 or f dash of 3. Next is g dash of 3. We'll try to find these values. I wrote some values on the board. Now, if I see the function f of 3, everyone in the class will tell me, boss, Venkat, don't waste your time, f of 3. When x is equal to 3, what is the value of the function is minus 3. So f of 3 value is minus 3. So simple. Everyone is able to identify that. Now, I need to find f dash of 3. So 3 lies here. So means this curve, this line slope. So this point is 2 comma minus 4. This point is 6 comma 0. So f dash of 3 is slope of this line, which is 0 minus of minus 4, which is 4. 6 minus 2, which is 4. 0 minus minus 4, which is 4 by 4, 1. So anyone has doubt, please ask me. I'm trying to explain the best that I can do. F dash of 3 is 1. F of 3 is minus 3. F of 3 is minus 3. F dash of 3 is 1. Now I need to find g of 3. What is my g of 3? Integral of g of x is integral of 0 to x f of t dt. So what would be my g of 3? Integral of 0 to 3 f of t dt. Integral from 0 to 3. I'm erasing this here. We got two values. F of 3 is minus 3. F dash of 3 is 1. We got these two values right now. Now I'm trying to find g of 3. What is my g of 3? G of x is this. So g of 3 is integral of 0 to 3 f of t dt. Means from 0 to 3 area under this curve. So this is half into base is 1, height is 4. So this value is 2. So but this is a combination of a triangle plus trapezium. So this and this will get cancelled, but no problem, do it again. So this area is half into 2 into minus 4, which is minus 2. So this is 2, this is minus 2. So both of them gets cancelled out. So now I need to find this area. So this is 4, this height is 4, this height is, this is 3, half into sum of the parallel sides, which is minus 4, minus 3 into this width, which is 1. So minus 7 by 2, minus 3.5. So g of 3 becomes integral of 0 to 1 f of t dt plus integral of 1 to 2 f of t dt plus integral of 2 to 3 f of t dt. So integral of 0 to 1 f of t dt is half into 1 into 4, which is 2. Integral of 1 to 2 f of t dt is half into 2 into minus 4, which is minus 2, plus integral of 2 to 3 is half into sum of the minus 4 minus 3 into height is 1. So final answer for g of 3 is minus 3.5. See how simply we are finding. We are not doing any magics. You are not required to know anything. If you are good in basics, directly you can go to the exam, but without practice you cannot do. So I am not asking you to, you should practice. But if your basics are strong, AP calculus is even other APs are so interesting. But AP calculus, if your base is strong, you can go and get 5 out of 5. But your base should be very strong. Now I got the value of f of 3. Now I got the value of f dash of 3. Now I got the value of g of 3. Now I need to find other simple thing, which is g dash of 3, which is most easy to me. Why? Because what is g of x? G of x is integral of 0 to x f of t dt. What is g dash of x? G dash of x is f of x. I'm happy. So g dash of 3 is just simply same as f of 3. So when x is equal to 3, we just found out it is minus 3. So g dash of 3 is minus 3. I got all the values. I got the value of f of 3. I got the value of f dash of 3. I got the value of g of 3. And I also got the value of g dash of 3. So let me go and plug in the function. Yeah, I got all the values. So f of 3 is minus 3. G of 3 is minus 3.5. F dash of 3 is 1. G dash of 3 is f of 3, which is minus 3. Since I solved, they're fixed in my mind. So if you solve like the way I solved, so g dash of 3, which is minus 3, f of 3, which is minus 3, G of 3, which is minus 3.5, f dash of 3 is 1. So 9 minus 3.5, 5.5. So P dash of 3 is 5.5. If anyone is leaving this question in exam, means you are committing a suicide. Means such an easy question. Means we are losing, we don't want to get marks. Just right. If you write so neatly, since it's a subjective paper, the person who is correcting your paper will be so impressive. Even you're making a minor mistake in other questions, the benefit of doubt goes to you. Means you can get extra one more mark. So part B is also done. If anyone still has concerns or the questions regarding the way I'm doing it, please let me know. Happily, I can explain. So P dash of 3 is 5.5. I'm very clear in my basic base that you are clear. Easy question, dead easy question. Part A is also easy. Part B is also easy. Part A is where the function is concave up. I just need to see where f dash is positive, these two values. Next is UV rule and differentiation. So that is also done. Next is asking to find the value. Is asking to find some value. What is the value? Is asking limit extends to 2, g of x by x square minus 2x. Very good here, very good question. So now part C is I need to find limit extends to 2, g of x by x square minus 2x. Now put 2, I'll get g of 2 by 4 minus 4, which is 0. What is your g of 2? Integral of 0 to 2 f of t dt by 0. What is integral of 0 to 2? This and this will get cancelled out. So 0. This is plus 2. Just now we did. This is minus 2 off into 1 into 4 off into 1 into minus 4. So this is plus 2. This is minus 2. Both of them get cancelled out. So integral of 0 to 2 f of t dt is 0. 0 by 0 is indeterminate form. So when I'm explaining limits, we discussed whenever we have indeterminate form, we can apply L'Hospital rule. So apply L'Hospital rule on this or L'Hospital rule on this. So the moment you try to apply L'Hospital rule on this, you get g of x derivative is g dash of x. X square minus 2x derivative is 2x minus 2. So limit extends to 2, g dash of x by 2x minus 2. Now you try to plug in the value of x as 2. So I get g dash of 2 by 2 into 2 is 4 minus 2 is 2. So I get g dash of 2 by 2. But I clearly know g dash of 2 is same as f of 2 by 2 because g dash of x is same as f of x. As simple as that. So what is f of 2? F of 2 is minus 3, so minus 3 by 2. So minus 3 by 2 should be your answer. Minus 1.5 is the answer. See how simple is this? How simple, and no formulas, nothing. Everyone can get 5 out of 5. Such an easy is AP calculus exam. BC exam is very easy. Easily can get 5 out of 5. See the way they're asking questions, basic questions. Only thing is your base should be strong enough. Your base is strong enough, you can do miracles. So there is one more part 2. Let us solve that part 2. So now let me go to the part 4. I hope I'm clear with part 3. Now let us move on to part 4. So when I'm solving part 4, the average rate of change of G. Okay, what is the meaning of average rate of change of G? What is the average rate of change of f of x in between A to B, f of B minus f of A by B minus A? This is my average rate of change, right? Yeah. Find the average rate of change of G on the interval. First, I need to find this answer. Once I find, does this mean value theorem guarantee a value C between minus 4 and 2 for which G dash of C equal to, okay, very good. So first we need to have clarity on mean value theorem. First, let me find average rate of change. So there are two things. Mean value theorem says the same thing. So first, let us discuss mean value theorem and then discuss the entire question. You might be able to feel better. What does the mean value theorem says here? Suppose if I have any function, if this function is continuous in the closed interval a comma b, so let there be one point which is a comma f of a, and let them understand the concept behind this. Let there be other point which is b comma f of b. Suppose if I have 2 points, what is the slope of this? Slope is average rate of change, which is f of b minus f of a by b minus a. If a function is continuous in the interval, closed interval a comma b, and the function is differentiable in the open interval a comma b, then definitely there exists a value c such that f dash c is equal to, there is a very good meaning behind this, f of b minus f of a by b minus a means, what is f dash of c says? Instantaneous change. What is f of b minus f of a by b? Average rate of change. So if the function is continuous and differentiable, definitely the average rate of change between those 2 points is equal to the instantaneous rate of change of the given function. That is what is the mean value theorem says. Now, right now, what I'm finding is asking me to find average rate of change. I get some value. Now he's asking, is there a c such that g dash of c equal to that value? This is asking, is the instantaneous rate of change is equal to average rate of change or not? As simple as that. So first, now let us find average rate of change. Then we'll see this instantaneous rate of change and everything. So first, I need to find the average rate of change of g between -4 and 2. So what is the average rate of change of g between -4 and 2? G of 2 minus g of -4 divided by 2 minus of -4, which is 6. So g of 2. So integral of 0 to 2 f of t dt. What is this? 0, because this is positive to negative, just what we have been doing. Now we need to find g of -4. G of -4 is integral of 0 to -4 f of t dt. Integral of -4 to 0 f of t dt, which is same as minus integral of -4 to 0 f of t dt. I'm correct, right? So g of 2 is integral of 0 to 2 f of t dt. What is g of -4? Minus into minus becomes plus, integral of -4 to 0 f of t dt. We clearly know 0 to 2 f of t dt is 0. This and this gets cancelled, positive and negative 2, so 0. So now I need to find 1/6 integral of -4 to 0 f of t dt. -4 to 0 f of t dt. So I can classify this into a triangle. I can also classify this into a trapezium, 2 parts. So what is the area of this triangle? Half into base is 1, height is 6. Half into 1 into 6 plus, what is this trapezium? Half into sum of the parallel sides, which is 6 plus 4, and the height is 0 to -3. So 0 to -3 is 3. So now 6/3 plus, what is this? 15. So 6/3 plus 15. I'm doing correct only, right? Yeah. Base is 3, height is 6 plus 4, half into sum of the parallel sides into height. So 6/3 plus 15, which is 45, which is 45 plus, so 2. This is 2, right? 6/2. Sorry, 6/2, which is 3. 3 plus 15, which is 18. So answer for 18 is this value. Which value? Integral of -4 to 0. 18 by 6 is 3. 1 by 6 into 18. 1 by 6 into 18 is 3. So the final answer here is should be 3. Which one answer? The average rate of change. The average rate of change for the given function should be 3. Okay. Someone says mistake is there. 1 second. Integral of half into base is 1 6. This is 3. Correct. Half into 10 into 3. Correct. So half into 10 into 3. Oh, sorry. This is -2 here. A small mistake is there. Correct. Half into 10 into 2. So this is half into 2 into 6, which is 3 plus 13. So sorry, a small mistake is there. So g of 2 minus g of -4 by 6. G of 2 is 0. Now g of -4 is integral of 0 to -4. That can be written as, finally we came up with 1 by 6 integral of -4 to 0 f of t dt. That is what we have come up with. Means I need to find this area because this area is 0. So this can be divided into a triangle and a trapezium. So area of the triangle is 1 by 6 into 1 by 6 half into base is 2 into height, plus trapezium is half into sum of the parallel sides, which is 6 plus 4 into 2. 2 or 2 get cancelled, 2 will get cancelled. So 1 by 6 into 16. Sorry, I just took 3, which is 16 by 6, which is 8 by 3. So G of 4, the average rate of change between -4 to 2 is 8 by 3. I hope everyone understood. Clear? Nothing. We're not doing any magic. Some basic calculation. So the average rate of change of G on the interval from -4 to 2 is 8 by 3. So answer for this part should be 8 by 3 units. Now see the question. What they're asking, the average rate change of between -4 to 2 for this function is average rate of change is 8 by 3. Average rate of change of this function is 8 by 3. Then will there be exist a C such that G dash of C is equal to average rate of change, which is 8 by 3. Is asking G dash of C is equal to 8 by 3. Just now we discussed what we have discussed. So function should be continuous and differentiable. Which function should be continuous and differentiable? G of x should be continuous and differentiable. From where to where? From -4 to 2. So if I can prove G of x is continuous from -4 to 2 and differentiable from -4 to 2, according to mean value theorem, the average rate of change should be equal to instantaneous rate of change. 100% correct, right? So we clearly know what is G dash of x. G dash of x is f of x. So clearly the function f of x is continuous and differentiable in this interval. So G dash of x, f of x is continuous. So G dash of x is continuous. Correct, right? So G of x is f of x is differentiable. So G dash of x is also should be differentiable. So now, since G dash of x is differentiable, G of x is also continuous function. G dash of x is f of x is differentiable, so G dash of x is also differentiable. Since G dash of x is differentiable, G of x should be continuous. So my function G of x is continuous and it is differentiable. Definitely there exists a value of C such that instantaneous rate of change is equal to the average rate of change according to the mean value theorem. That's it. So simple. So definitely there exists a value because the function is G dash of x is differentiable and continuous. So my answer is yes for the third part. Why? Because G dash of x is differentiable, so G of x is continuous. Hence, according to the mean value theorem, G dash of C equal to 8 by 3. There exists a value C in between -4 to C such that G dash of C equal to 8 by 3. As simple here. If you can do this, you'll get 8 points or 9 points or 10 points, whatever the points that you want, you'll be getting. Any doubts in this question, please let me know. This also is such a simple question. I'm not required to know any hi-fi things. You just need to know what is the meaning of concave up. You need to know UV rule for second question. You need to know what is L'Hopital rule for third question. And you should know what is the meaning of average rate of change. And you should know just mean value theorem. Even if you don't know, when you're solving this question, you need to get hold of that concept. How many things you are learning. So that is the reason you solve 5 last year papers. Sincerely, 5 into 6, 30 questions. You learn all the concepts of AP Pakka. This is our 4th question. Now let us move on to the 5th question. Let us see how to solve 5th question. What is this? Yeah.